All right, Math 111, section 10.2, page 4 of the notes. We are determining if these data values are what we call statistically significant. We have two different approaches. We have the classical approach, which was the previous video, and this new approach called the p-value approach. In the p-value approach, we compare the probabilities, the areas, to determine is the point estimate whether it falls in the critical region or it does not, whether we reject the null hypothesis or fail to reject the null hypothesis. So this problem right here is exactly the same as the first problem in the previous video. There's a typing error in your notes, and that is using the p-value approach. That's pretty important right there, to test the hypothesis at the given significance level. So every data value, all these values are exactly the same. Let's see if we get the same response and reject the null hypothesis. First, you have to check this, and as before, it satisfies that so that we can continue. But if we don't have enough data values, if the n is not big enough, we're going to have to stop the problem before it even starts. Okay? This we can use our calculator for. This was used on a TI-84, and it prompts you to enter these four parameters. On the 36X Pro, we are entering those parameters, but in a different format. So you turn your calculator on. Hope you guys can see this stuff. We still calculate what x over n in a right-tailed test. That's the lower bound, okay? So a picture of a right-valued test would look like this, and we're looking to see if our data values live up in there. The lower value is this positive score, and the upper value, which could be positive infinity. Actually, positive 1 works equally as well. When we're talking about areas under this and with probabilities, the sum of every data value that lives under here is going to be 1. So the upper bound could be 1. It could be positive infinity. It could be 1,000. It could be 100,000. Just to make sure, I like to type a bunch of zeros. This right here, that's the mean value or the test value. And then this is what we call sigma. The sigma on this is, well, I should put the formula down here. It's P 1 minus P, and N, and you take the square root of that. That's the fourth parameter on a TI 84. Let's see how it looks when we put it in our 36X Pro. So we go to distribution. We want to find the comparative z-score, the normal CDF. We want to put in there the mean, 0.3, the sigma, this yucky value. I should have pre-calculated it, but since I didn't, I'm going to throw it in right now. The square root of parentheses 0.3 times 0.7 divided by 200. And we press enter or we arrow down. Either way will work. The lower bound is what we discussed earlier. That lower bound is the x divided by n value, or the 0.375. And the upper bound is like positive infinity. So this is 1 times 10 to the 99th power. And we're going to calculate that. That should be the p-value, the z-value, or the z-score that we can compare to. So far, so good? We're going to compare that z-score value right down here to our original alpha value slightly different than the classical approach. And since this is smaller than that, we are going to reject the null hypothesis. Let's take a look at sample number 2. Now, this one on this page is slightly different than the one on the previous page. Let's take a look and see what this thing looks like. On the previous page, we were comparing values on both tails, a two-sided test. On this one now, it's very similar to the one right up above it. And the one right up above it, we were doing a right-tailed test. This one's a left-tailed test because we're checking if our p-value is lower than that, okay? So let's see if our sample size is big enough. We put that in there, that's greater than 10. We keep going. We need to calculate what the x over n value, and the x over n value is pre-calculated here. Again, we would put these values in there, except for this time, the lower bound is negative infinity, and the upper bound is this 0.6 value. Does that make sense? So let's check our p-values to see if we can accept or reject this null hypothesis. Let's turn our calculator on. The 4 data values that we need, I think we will have. We'll just compute that one like we did the last problem. Oh, so say solve again. Here we go. The mean or the p-value, 0.6. The sigma value, to calculate the sigma value, it's the square root of .6 times 1 minus 0.6 divided by the number in this set, 250. Arrow down. The lower bound, this time, negative infinity. So I'm going to put negative like 1,000, negative 10,000. And the upper bound on this specific instance, the upper bound is this x over n value, 0.496. 0.496. Hit it. So this determines a z-score of comparison of 0.00039. 0.00039, super duper small, okay? But how is it compared to that? It's smaller. So the point estimate does lie in this shaded region, so we will reject the null hypothesis. Okay, so if it lies in the shaded region, we reject it. If it doesn't lie in the shaded region, we fail to reject it. I hope these 2 videos come in handy for you. Shoot me an email if you need to see anything else. We'll talk to you soon.